In this video, I'm going to be talking about how to derive projectile motion. So in this case, I'm only doing the derivation, but there will be slightly somewhat of an example that I'll be doing. So basically, I'm going to calculate what the time is, what the time it takes to reach the ground again. Okay, so that's one of the examples that I'll be doing. But mainly, this is just focusing on the derivation of projectile motion. Okay, let's get started. So suppose I have some sort of mass. So let's say it's a ball, right? So I'm going to project it at some angle theta and with the velocity v, right? So I'm going to project it like this, and then it's going to land after a certain distance. Okay, so I don't know what this distance is. And just in case you're wondering, it doesn't have to land on the ground, but that's usually the questions, how the questions are structured. It could be off a cliff that I'm doing this, right? So suppose that's a cliff, and I want to calculate how long it'll take before it hits, say, the sea, which is 20 meters below. Okay, so this will just give you the tools and show you how to do this kind of question. Okay, let's get started. The basic equations that you need to show is that we're going to be dealing with acceleration. Okay, so I'm going to assume that there is a downward acceleration of g, and there is no air friction. Okay, so there is no air friction. It's simply a downward motion, downward acceleration, as we say. Okay, so basically, what I'm going to end up saying in the y direction, right, which is the up direction over here, the acceleration is minus g. On the other hand, the acceleration in the x direction is equal to 0. Now this, some people might think it's a bit weird, but you need to understand there is no air resistance, right? So if so suppose I was traveling on a bus, right? So say it's going at 20 kilometers an hour, and you happen to chuck a ball at this point. Ideally, what you should see is if there is no air resistance, the ball should drop down straight away. So basically, the ball should keep traveling with you until it hits the ground. Okay, so if there is no air resistance, that's usually what happens. Okay, but anyway, that's clearly what you wouldn't observe because there is air friction. But anyway, let's keep going with this. So if y double dot, which stands for acceleration in the y direction, is minus g, to get y dot, all I had to do is integrate this. So in this case, y dot is going to be minus gt, because remember, acceleration is velocity over time, right? Change in velocity over change in time. So if I was to take the dt onto this side and integrate both sides, I will end up getting velocity, which is my y dot, is equal to minus gt. Of course, there's going to be a plus c term. Okay, as any integration, there is a plus c term. And to figure this out, what this plus c is going to be, I need to figure out at t equals 0, what is my velocity in the y direction. Okay, so the velocity in the y direction is simply going to be this velocity times sine theta. Okay, so because this is the component in the y direction of the original velocity. Just because I've done this right now, I'm just going to tell you that Vx is going to be equal to V cos theta. Okay, so all you're doing is taking components of this velocity into the x-axis and onto the y-axis. Okay, so basically, if I was to add these two up, Vy squared plus Vx squared, this will be equal to V in brackets sine squared theta plus cos squared theta, which you all of course know is equal to 1. Okay, so it just ends up being velocity that you start off with. Okay, let's move on. So if at t equals 0, my velocity is v sine theta, my c, so what I'm saying is v sine theta is equal to minus g times 0 plus c. So guess what? C is equal to v sine theta. So I have y dot equals minus gt plus v sine theta. In the same argument, I'm not going to derive the entire thing, but I will end up getting x dot is equal to v cos theta, because 0 times t plus c. So this, in this case, will end up being v cos theta. Okay, I need to do this one more time to get y. So this is the displacement in the y direction. So remembering that y dot, or my velocity in the y direction, was actually dy dt. I can again take the t onto the other side and integrate both sides to end up with y is equal to minus g t squared on 2. So you need to remember how to integrate these things, plus v sine theta t, and of course you have your plus c, but this time plus c will end up being equal to 0, because if you go back to our diagram, I'm defining this point to be 0, the origin. Okay, so at t equals 0, y is equal to 0. So if I was to sub it in here, if I was to sub it into this equation, you'll find out that c is equal to 0. So I'm going to ignore that term. Okay, and in the same manner, I'm going to find that my x is actually equal to v cos theta t. Okay, so we have these two main equations. Okay, so my first question is, how do you calculate when the ball lands? So how far has it traveled, right? So in this direction, how far has it traveled before it lands right there? Okay, so what's the distance? And to do that, I'm actually going to look at the y equation, not the x equation. So first of all, I'm going to look at the y equation, and then I will look at the x equation. So the trick is, you know that at a certain time when it does land on the ground, y over here is equal to 0. Okay, because as soon as it lands, well, actually, when it starts off, y is equal to 0. And also when it lands, again, y is equal to 0. So that's really important to understand. So once you understand that, you can go ahead and solve this equation. 0 is equal to minus g t squared on 2 plus v sine theta t. And guess what? This is a quadratic, right? So I can factorize t out. So I will get in brackets. So I'll look at this term first. So it gives v sine theta minus g t on 2 equals 0. So the solutions are either t equals 0, so at t equals 0, y equals 0, which is obvious because that's where you start off from. And the other equation solving this thing equals 0 is that you will end up getting t is equal to 2v sine theta on g. Okay, so that's the time that it takes for it to hit the ground. And this thing, I'm going to sub it back into here. Okay, so I will end up getting x is equal to, okay, so just copying this down, I will end up getting x is equal to v cos theta times, so that'll be a 2 times v again, so put a v squared up here. Okay, so v squared sine theta, I really shouldn't have put the 2 over there, but anyway, just keep up with me. So sine theta, and I'm really sorry that I'm cramming over here, all over g. So anyway, simplifying this, I will end up getting x v squared, 2v squared sine theta cos theta all over g. There's one tiny little trick that you probably should do, and that's to recognize the fact that 2 sine theta cos theta is actually one of the known trig identities, right? So x will end up being v squared sine 2 theta on g. So this sine 2 theta trick is actually a known identity. 2 sine theta cos theta is sine 2 theta. Okay, so there you go. So that's how far it will travel. Okay, right, so we have this. The last thing that I'm going to do is to get an equation between x and t. Right, so to get an equation between x and t, I need to come back here and look at these two. Okay, so these things. Okay, so at any point in time, what's the relationship between x and y? And to do that, all you need to do is eliminate the parameter. In this case, the parameter is t, right? So t is what I want to eliminate. And in order to do that, I need to make t the subject over here. So t is equal to x. So it's equal to x on v cos theta. Okay, and we also know that y is equal to minus gt squared on 2 plus v sine theta t. So what I'm going to do is I'm going to sub this t over here into these two. Okay, so that'll get our x for us. So solving this one, what will we get? So we'll have y is equal to minus g times g on 2, I should say, times x squared on v squared cos squared theta. And then this term over here will be v sine theta times x on v cos theta. Okay, great. So I will have a cancellation over there. And then over here, what I would end up with is, okay, this cos squared over here, I'm actually going to write it as sec squared. Okay, so it's sort of important. It's not too important, but anyway, we'll see what happens. I will x squared times sec squared theta. And over here, what I will have is x tan theta. Okay, and what I'm really getting at over here is the sec squared theta. It's depending on the problem, it might be actually useful to write that as what is it, tan squared theta plus 1. Okay, because it turns out to be a quadratic in tan theta. Okay, but that's obviously optional. It depends on the question, what they're asking, but just keep that in mind. So that's it for my derivation. So this is what I had. If you have any questions or comments, let me know, but please do subscribe, and thanks for watching.